Good day, everyone. We are still busy with factors and remainder theorems. This time we are going to solve cubic equations. So that means we are solving for x. And normally when you are solving a cubic equation, the degree, which is the highest power of x, should be given you direction as to how many roots do we expect. So in each of them, we expect 3 roots. So let's go to the first one. So I always like to call my function f of x. You can still choose to call it anything of your choice. So if the question is just given to you bluntly like that to solve for x, and where no other factor is given to you, know that the only way you can solve a cubic function is through the factor theorem. So your very first step is to try to get a number that you can substitute there until you get 0. And usually you can try as many numbers as possible, but to limit your numbers, look for factors of the last term or the constant term, sorry, not last term. So factors of the constant term are numbers that this constant term can easily divide without a remainder. You see the constant term is negative 14. So the numbers you can divide is plus and negative 1, plus and negative 2, plus and negative 7, as well as plus and negative 14. So those are 8 numbers. So when we are solving by factors and remainder theorems, we need to substitute any numbers of our choice, and we must target the factors of the constant term, which are 8 of them. So you have to try them until you pick the one that will help us. So if I start with maybe a positive one, put positive one right through. The first term will be 1 minus 6 plus 15 minus 14. 1 plus 15 is 16 minus 20. You see it's not equal to 0, so discard 1. If we try negative 1, this will be negative 1. Then minus 6, because negative 1 squared is 6. Minus 15 minus 14, it's again not equal to 0. So it means these 2, we discard them. That's how you try it until you see the one that will get you to 0. So if we go to 2, for example, 2 cubed is an 8, 2 squared is a 4, 4 times negative 6 is negative 24, 2 times 15 is a 30, then minus 14. So if I check them, these 2 give me 38, and this one also look like 38. So 2 has equals. So I'll have to start by saying f of 2 is equal to 2 cubed minus 6 into 2 squared plus 15 into 2 minus 14, and that gives me 0 for my calculation. Once it gives you 0, your conclusion is that x equal to 2 is a root of f of x. If you have started by calling your function f of x, then x equal to 2 is a root, which also tells you that x minus 2, if you take 2 to the same side as x, is a factor of f of x. So this is just to remind you that when something is a root or a factor, those are the things that you pick up. The f of 2 must give you 0 to show that x equal to 2 is a root of f of x, or that x minus 2 is a factor. So it means to solve for x, we are actually looking for 3 roots. We've succeeded to get the first one through trial and error method. Now to get the remaining root, there are 3 options. There is long division, there is synthetic method, there is inspection. But I always like to do synthetic method, which I will take you through it. Synthetic method, we are doing a division with the root that we've just picked going outside. So I'll put 2 outside. Then in here, I must have 4 numbers, which are the coefficient of x cubed, x squared, x, and the constant. So the coefficient of x cubed is that number in front of x cubed, which is 1. The coefficient of x squared is negative 6. The coefficient of x is 15. And the constant term is negative 14. So those are my 4 numbers. Then I start with my addition. So I'm doing addition. Under the first number, I always start with a 0. Then I'll take 1 plus 0, which gives me a 1. Then whatever goes down here, you multiply it to the root. 1 times 2 is 2, I'll put under the second number. Then negative 6 plus 2 is negative 4. Then I'll take 2 times negative 4, that gives me negative 8. I'll put under the other one, the third term. Then 15 plus negative 8 is like 15 minus 8, which is a 7. 7 times 2 is a 14. Then negative 14 plus 14 should give you a 0. So what we expect from you if you did the right division is that you must end with 0. We start with 0 under the first term, we end with 0 under the last one. So from here, we are now having a quadratic down here, which if we solve that quadratic, it will lead us to our remaining 2 roots. So we are now going through the aspect of solving that quadratic. So there is a quadratic hidden down there called x squared minus 4x plus 7 equal to 0, which now to solve it, we can use our quadratic formula. We all know our quadratic formula to negative b plus negative the square root of b squared minus 4ac and 2a. Our b is negative 4, the coefficient of x, then plus negative the square root of b squared means negative 4 squared minus 4a is 1, the coefficient of x squared, then c is 7 divided by 2a. So if I move on, I will get a 4 there, plus negative, the square root of negative 4 squared is 16, 4 times 7 is 28, so we have 16 minus 28, that gives us negative 12 over 2. So this kind of quadratic that have ended with a negative sign under the square root shows that you can't just handle them using your calculator. You need the help of complex numbers to step in. So we are going to bring it in now. So we get 4 plus negative. We use our root 12, then times the root of negative 1. 12 times negative 1 still takes you to negative 12 on 2. Then this will tell us that we've got 4 plus negative. If you take root 12, the square root of 12 is 2 root 3. 2 root 3. The square root of negative 1 is always an I or a j, which can then lead you to the other two values of x. So you take 4 divided by 2 gives us a 2 plus negative 2 root 3 divided by 2 gives us root 3i. So at the end of the day, we've succeeded to get our 3 roots, or we solve for x, and when we are solving for x, the degree must tell you how many roots or how many answers you expect. If the degree is 3, we got the first root x equal to 2 through trial and error, and the others we had to do factor theorem, which then led us to a quadratic, which we solve to see that we've got 2 plus root 3i and 2 minus the root 3i. So we've got 3 roots, 2 of which are complex, and 1 is a real number. So that's how we've done number 1. I don't know why I keep calling it A. This is number 1. Then let's move on to number 2 and solve for the 3 roots again. Or when you're solving for x, you look at the degree all the time. So again, I would like to call my function f of x, which is 3x cubed minus 7x squared plus 4. So that is my function. So I need to get the root, or I need to solve for x. So we have to start with the trial and error method as before. So we need to substitute numbers until we see 0. So to guide us, the constant term should step in, and we look for the factors of 4. There should be plus and negative 1, plus and negative 2, plus and negative 4. So there are 6 numbers that can divide 4 without a remainder. So if I start with 1, if I put 1 there, this is 3, plus 4 is 7, minus 7 is 0. So thing 1 has just solved our problem. So if we take f of 1, that will be 3 minus 7 plus 4, which is 0 as before. This shows to us that x equal to 1 is root of f of x, which also tells tells me that x minus 1 is a factor of f of x. So, out of the 3 roots that I'm looking for, I've seen one already, which is x equal to 1. So now I'm left with 2. So I will do my synthetic method as before. So outside, we need the root we have identified, which is 1. Inside, we must get 4 numbers, even though we've got 3 terms. Here it was easy because we've got 4 terms. It was easy to pick them, but with cubic functions, we always expect 4 numbers in here. So my first number is a 3, my second is a negative 7, 3 is the coefficient of x cubed, negative 7 coefficient of x. Then you see the interesting thing here that my third number is a 0, because I don't see any coefficient of x on my here. There was x whose coefficient was 15. If one term is missing, then its coefficient is 0. Then the last one is a 4. So you see with cubic functions or third degree polynomials, we always expect 4 numbers in here, even if the original function has only 3 terms. Then we go on with our addition. We add 0 under the first number. 3 plus 0 is 3. 1 times 3 is 3. Negative 7 plus 3 is negative 4. 1 times negative 4, we always multiply the numbers down there to the root. It's a negative 4, you go under the next. 0 plus negative 4 is negative 4. 1 times negative 4 is negative 4. And negative 4 and 4 plus negative 4 is 0. So as long as you end with a 0, then you're on the right track. So we've seen one root as indicated. We're left with 2. The 2 is in this quadratic. So what is written here is a quadratic. 3x squared minus 4x minus 4 equal to 0. So I will pass it through my quadratic formula as I did this side. So I will get negative b. My b is negative 4 plus or negative the square root of b squared. That is negative 4 squared minus 4a. My a is a 3. This time my c is a negative 4 divided by 2a. So if I take my time and go through this, this will be a 4 plus negative the square root of, if I analyze this, this is 16. Then this is 16 times 3 is positive 48, so I'm just checking what is 16 plus 48, that gives me the square root of 64, or that one 6. So this time we are lucky, the number under the square root is not negative, so that shows to us that we can work with our calculator. All our roots will be real root or real numbers, no complex. So the square root of, so here our square root of 64 is 8. So it means we have 4 plus 8 on 6. If I start with a positive 1, 4 plus 8 is a 12, on 6 is a 2. Then the other one is x equal to 4 minus 8 on 6. 4 minus 8 is a negative 4 on 6. That gives me negative 2 over 3. So therefore, my 3 roots for this function are x equal to 1, x equal to 2, and x equal to negative 2 over 3. So guys, that is how we solve a cubic function. Once we solve it, we must get 3 roots. And just to add to what we have done with this kind of a function that doesn't have complex root, they could have asked us differently by saying we should factorize. So if I'm told to factorize, I think the best option will still be to follow what I have done. Then from your factors, from your root, you can create your factors like I was doing here. If I'm creating a factor, I just take it to the left. So for example, if I was factorizing this, I will just create this factor. From here, it will be x minus 1. That's my first factor. then the other one will be x minus 2. Then this is the interesting one. This one is interesting because you can't leave it that way. You have to cross multiply first, which means if I cross multiply, 3 will go there, and I will get 3x is equal to negative 2. You see that? Then I can take that one outside to show that my factor is 3x plus 2, and that way I can write my f of x in terms of the factors as x minus 1 into x minus 2 into 3x minus plus 2. So when it comes to complete factorization, you could still do your stuff the same way, solve for the root, but when it comes to this one that are fraction, you cross multiply first and do something like this before you get your factors. So guys, I hope solving for x in a cubic function helped you. Thank you very much.